I must be misunderstanding what you're asking.
I'll explain again. The GP ground position of the star will have 90 below it as detailed by Harold Jacobi. Do you understand, yes or no?
Yes.
At the ground position on this ball, it will not be 90 degrees anymore.
Why not?
Because it's curving. Curved lines don't meet 90s, do they, boy?
They do. Ask any geometry professor. Yes, that's my answer.
Yeah. Now I'm saying if I can get somebody to unequivocally demonstrate to you in a position of authority that understands this stuff, that no, you cannot acquire 90 from a curve, that you'll resign. You've said yes.
Yes, of course.
You think you can get 90 from a curve? Or not to a curve, from a curve, just to be sure.
Okay.
At that point, yes.
Okay.
Now, yes.
So
Okay.
we just need to get somebody in authority to confirm to you that 90 degrees isn't possible, and you will resign.
Yeah, good luck with that.
Okay, we'll see how we get on, Matthew. And when we achieve it, I will expect your resignation. And if you don't give it, I will submit this to your superiors.
I'm confident enough in my understanding of mathematics to put my job on the line. Yeah, what's on the screen? Oh wait, so I'm looking at.
It's you posted it. It's celestial navigation that he's detailing. We just clarified that 3 minutes ago, Matthew. Struggling to keep up? Yes, back to the original do-si-do round the circle with a shyster. That's right, you specifically said it doesn't use 90. Here it is using 90, and it's being used in celestial navigation. That's what's being done in the video and detailed by a professional who saved people's lives by doing it. As opposed to you who says, do you want to know why it's wrong? I've never even held a sextant, but I know, trig. He's doing celestial navigation, though.
So to clarify, I say that true celestial navigation does not use right angle triangles. Therefore,
it's on screen now. There again. It's on screen now using 90. True celestial navigation as detailed by a navigator.
Right, and so
right.
Drawing that
so double speak much, clown? Yeah, right. It does use 90. So do you want to start your sentence again for the third time saying it doesn't? Well, now you've clarified for the second time that it does.
True celestial navigation does not use right triangles, therefore.
But yeah, it's on screen now with a right triangle from a navigator.
Yeah, and so that's why it's wrong, because it has a right triangle.
So in conclusion, the navigator who is a professional is wrong, and he details it the same way as we detail it, making us also wrong, even though he's a professional paid to do this.
Right.
Okay. So have you contacted him to say he is putting lives at danger when he was paid to do this wrong?
No, I mean...
No, but I'm calling for your educator to fire you because you're teaching kids wrong and a shyster. Do you see how that works? I am calling for your job because you are a shyster. You are saying the navigator who's a professional paid to save lives is wrong because you've never held a sextant and no trig.
Well, so do you think his diagram is right?
No.
Well, given that it matches up every single book on celestial navigation I've read ever, I'm going to go with yes.
What do you mean by his method is right?
Well, it's the same method detailed in every celestial navigation book you'll read, ever.
And there's part of one in Discord right now. Matthew, from Harold Jacobi, professor in astronomy, the sextant, navigation, chapter 6. It's very short. Can you read that for everyone, please?
He says, this height of the sun or of any star in the sky is called its altitude. And so the altitude is always an angle to be measured in degrees or minutes. The point directly overhead is the zenith. The angle between the lines drawn to the horizon and the zenith is 90 degrees or a right angle.
Is Harold Jacobi also wrong?
No, that's correct.
That's you being wrong.
Straight up,
so Matthew, Matthew, let's see how much humility you have. So it is in fact you that are wrong when you say it doesn't use 90. It's not Harold Jacobi, us, and this professional navigator who are wrong. It's you who are wrong when you say it doesn't need 90, because it factually does, and every reference to celestial navigation will require a flat Earth with 90 at the GP of the star, ground position. You are wrong, Matthew. Not Harold Jacobi, not this navigator, not me, you. Well, ladies and gentlemen, that stony silence was how much humility Matthew Learns has. He is wrong. Harold Jacobi's just demonstrated how wrong he is when he details the 90 that is required, that he says isn't. Yeah, this is just celestial navigation, it needs 90. You're wrong, Matthew. You have no humility.
I posted how celestial navigation works on a globe, and there is a right angle.
So it works on a globe? How'd you get a elevation angle measurement from a curved adjacent? That'd be a curved Earth.
90 degrees from the zenith would be one way. But I'm talking about the 43 past the hour.
An elevation angle measurement is what I'm talking about. How do you establish a horizontal baseline if you have a curved adjacent?
You can establish a horizontal baseline, which is 90 degrees from a plumb line. That would be the way to do it.
To the GP also at 90?
The GP is also at 90, but it's
so the baseline isn't curved then.
The baseline between you and the GP is curved.
Sack him, just fire him. Contact his employer, tell him he doesn't understand what 90 degrees are, he doesn't understand what triangles, he thinks that angles have curves. No, Matthew, you can't establish a horizontal baseline if you have a curved adjacent. It wouldn't be an adjacent. Matthew, Harold Jacobi isn't wrong. This navigator I've got on screen isn't wrong. And I, Nathan Oakley, the flat earther ripping your asshole through your throat, is not wrong. You are wrong. 90 is required. So 90 degrees below the star, the ground position would not meet the spherical surface then to have 90. So the 90 degree you do use in celestial navigation will not be the, as labelled in this diagram, GP, because it will not be on the ground at 90, will it? If you say yes, it does meet the ground at 90, I'll point out how wrong you are. You just need to not so and rumpus your way past this. There would be 90 required at the ground position. That is not afforded to you on the sphere. 90 does not meet the sphere ground, does it, Matthew?
It does. The angle of that line. You think
that this here, this point here, on the ground, below where anything is labelled, that would be below the star, as I am pointing out to my audience, here on this yellow or green or whatever line, that's where it would have a 90. Below it, wouldn't, because you would have a curved adjacent, wouldn't you?
Right, that's why you can't.
Right, now shut the below the GP of the star, that's the ground position. The ground position, which will have 90, will not be meeting the ground sphere surface, will it?
I must be misunderstanding what you're asking.
I'll explain again. The GP, ground position of the star, will have 90 below it, as detailed by Harold Jacobi. Do you understand, yes or no?
Yes.
At the ground position on this ball, it will not be 90 degrees anymore.
Why not?
Because it's curving. Curved lines don't meet 90s, do they, boy?
They do.
You think a curved line meeting a straight line makes a 90, do you?
It can, yes.
You think a curved line meeting a straight one makes a 90?
Ask any geometry professor.
They'll say no.
Let's use AutoCAD.
Which on what the guys over at Flat Earth Debate have been saying, we're going to use the exact same examples of the GP positions here. If we're standing here on the Earth presenting the horizon, the angle formed here is definitely not 90 degrees at the position where it meets the Earth. You can't have a 90-degree angle to a curved surface. If I choose the angular dimension command, if I try to pick this line and this arc, it says here, object selected is not a line. So it will just not give me an angle. And why would it?
Did you follow along with that, Matthew? Do you understand my disdain and outrage for your stupidity? Curved lines don't give you 90s.
I'm a bit at a loss because I heard the audio, but I didn't see the video. But he's using AutoCAD, and AutoCAD, I don't know how AutoCAD works, I guess.
It just applies geometric principles like curved lines not giving you angles, Matthew, like I tried to disseminate to you.
So we want you to bring those trigonometry professors in here.
No, don't try and get him to hurl other professionals like the navigator under the bus. No. No, this is just Matthew, hence me asking for him to be sacked. I've asked him on his own diagram where you get the 90 he read out from Harold Jacobi is required and how it will not form 90 at the base on the sphere surface. Yeah, meaning it fails. I didn't ever get to make my conclusory point because he couldn't concede he's got no humility. Meanwhile, we've had somebody else do it in AutoCAD. And he's still like, oh, maybe the AutoCAD's wrong. Everybody's wrong but him. Right, Matthew? The AutoCAD's wrong, the navigator's wrong, Harold Jacobi's wrong, we're wrong. It's only you that's right.
Then he said, you can ask any trigonometry professor about the 90 at a curved surface.
Well, maybe if we do, if we ask somebody who's in authority, in other words, in a higher position in the education structure than you, if you're right and you're wrong, will you resign?
Well, yeah, if I'm wrong, I definitely resign.
So if I can get somebody who's professional and understands this stuff, I asked you about whether or not you could have at the surface of the sphere 90 degrees meeting it. You said yes.
Yes, that's my answer.
Yeah. Now I'm saying if I can get somebody to unequivocally demonstrate to you in a position of authority that understands this stuff, that no, you cannot acquire 90 from a curve, that you'll resign. You've said yes.
Yes, of course.
I think you can get 90 from a curve. Not to a curve, from a curve. Just to be sure. Say it that way.
So let's get the question right. He's saying that you can get a 90 degree from a curve between a curved adjacent and the opposite. Correct? Yes, Matthew? Matthew, yes?
Not a curved adjacent. I'm talking about a angle.
You're saying you can acquire that from the curved adjacent. A minute ago, you were prepared to put your job on this. Now you don't seem to be answering me.
A right angle, 90 degrees. One is a sphere, one is a
geometric
line.
objects.
So I'm being very
Sorry,
specific.
Matthew, these geometric... We're talking about stars. Your diagram had a star in it. Sorry, Matthew.
Yeah, so I'm trying to be precise about geometric objects.
We just go back to your diagram. That's what I was quizzing you on when we got to you putting your job on the line for it. The diagram, you were following me along with the different colours of lines. You definitely knew what I was talking about. Yeah.
I was simplifying.
The base of the triangle, the one that you said we don't have, that aside, that's going to be 90 degrees at the GP of the star. You confirmed. Yes.
Right.
Harold Jacobi said it. Yes. I said that is not 90 degree to the sphere surface. You said yes. I said, are you prepared to put your job on it? You said yes.
Yes, of course.
Okay. So, therefore, 90 degree at the ground position will be meeting a curved adjacent. Okay.
At that point, yes. Uh-huh.
Okay. So we just need to get somebody in authority to confirm to you that 90 degrees isn't possible, and you will resign.
Yeah, good luck with that.
Okay, we'll see how we get on, Matthew. And when we achieve it, I will expect your resignation. And if you don't give it, I will submit this to your superiors.
I'm confident enough in my understanding of mathematics to put my job on the line to say,
Okay, so
state it in the way that, go ahead and state it in the way.
Again,
clearly
no worries.
that
I've done it
want
with you. You followed along the first two times. Here, the star being measured from this position off a spherical surface in your diagram. According to Harold Jacobi and confirmed by you, this is the fourth time we have done this. That ground position meets the ground at 90. You have affirmed. I say,
Yes.
well, then it can't meet the sphere surface at 90. You say it can.
It can.
You will resign.
Yes.
Okay, then we are all clear.
You think that somebody is going to agree with you? Like some math guy is going to agree with
I
you?
guess we'll find
This is
out.
basic fucking geometry.
No, that's okay. No, you're clearly confident that we won't find somebody and your job is safe.
Yeah, that's right.
Okay, well, we'll see how we get on, won't we? I'm sure you're very confident.
Yep.
Start packing your bags, crayon muncher.